This video is looking at how we look at the process of refraction, and to do this we use a glass block or a perspex block. So the first step of drawing a ray diagram for refraction is that you draw around your glass block, and as with the previous videos I'm doing this in pen so that it stands out on the video, but you should always do this in pencil in class. So I've drawn around my glass block like so. I'm going to move my glass block out of the way for a second. So what we're going to do is we're going to fire in our ray of light into our glass block at 3 positions to see what happens. Okay. So first of all, I'm going to fire it in a perfectly straight line. So I'm going to fire it in 90 degrees to the surface, effectively along the normal line. Okay. Second thing I'm going to do is I'm going to fire it in at an angle to the surface. And third thing I'm going to do is I'm going to draw I'm going to do it again at an angle, but I'm going to do it much closer to the edge, but I'm going to do that last. So once I've drawn on where I'm going to fire my rays of light, now I can actually do it. So what I do is I put my glass block back into the position, make sure I line it up. And I take my ray box, turn the light on, and we're going to use the single slit for this experiment. So I'm going to put a single slit in there. So I have my ray of light, and I'm going to line it up so that first of all it travels straight along the line that's perpendicular to the surface. And just like before, I'm just going to mark 2 points, 1, 2, and also where it comes out of the glass block as well. And then what I'm going to do is I'm going to do it along this angle, and again I'm going to mark on 2 points, 1, 2. I'm also going to mark on where it comes out of the glass block, and then I'm going to turn my ray box off. That's done, and move my glass block. So now what I need to do is I need to join up these lines. So I exited the glass block here and came through in a straight line that way. This one exited the glass block at this point and came out there. So I've got my ray of incidence and the angle it's come out. Now what we do is we can make an assumption now that the ray of light travels in a straight line inside the glass block. So all I need to merely do here is to join up these 2 lines, like so, and like so. Now what you can see is that when the light shines 90 degrees to the surface along the normal line, it travels straight in a straight line and is unimpeded. When it hits at an angle, however, you can see clearly from above that the ray of light has been bent. It doesn't follow a perfectly parallel path. So for example, for a perfectly straight path. So if I was to use my ruler, you can see this, that the ray of light that comes in, this line here along the ruler, is where it should have gone if it had gone through in a straight line. But you can see when it hits the glass block, the ray of light is bent and then goes back down. But you can see these 2 lines are parallel to each other. So the process of refraction is the bending of light. Now the other thing we want to do is that, particularly with this diagram, is we want to be able to measure the angles. So we need to include a normal. So just like before, make sure we line up the 90 along the surface, and where it hits the glass block we're going to draw a dashed line for our normal there, and we're going to do the same thing here. So line up the 90 along the surface and draw our dotted normal line like so, and we get interested in measuring each of these angles. Okay, so we have the angle of incidence, and in this case theta r is the angle of refraction, and then we have the same here. So let's measure these. So we always measure it from the normal. So I'm going to put my center point along the normal, make sure this line 0 comes along the normal, and measure it. And if like this, if you have difficulty because it goes off the edge of the protractor, what you can do is you can extend your line to get a more accurate measurement. So this is 34 degrees going in, and then from here to there, after it's entered the glass block, the angle now, you can see, is much smaller. It's about 22. I'm only doing this very roughly. Here, from this point, go along normal again, look, and if you look carefully, you'll see again, this angle is 22. And you may be able to predict what's going to happen at this point. So I line that up, come along, and again, I get 34. So you can see that these two lines really are parallel to each other because they've entered and exited the same material, the same medium. The light is bent by the same amount each time, but just in the opposite direction. So when you go from here, we had air, here we have glass or perspex, and then we go back to air again. So when we go from a material that is less dense to more dense, what happens is that the ray of light bends towards the normal. Okay, so the angle has got smaller. When it goes from a material that's more dense, like glass, into air, which is less dense, then the ray of light bends away from the normal and the angle gets bigger. And that pattern happens in all situations where we have refraction. Now I mentioned that there was a third experiment, which I'm going to include here and then do another video on in a second. So if I put my ray of glass block here again, and I turn my ray box back on, I'm now interested is if I take this line but bring it close to the edge. So we'll watch carefully what happens to the path of light here. So as I bring it close to the edge, all of a sudden you can see at this point it appears to change direction. Okay, so I'm just going to indicate on here. So I've got 1, 2, and then where it crosses. And I'm going to do where it comes out. Okay, and I'm going to just do this in red, just so that it stands out on my diagram. So I've got my ray of incident that comes out, and I've got my ray that finally leaves the glass block on the other side. So we have to understand this process of what has happened in this case, and for reasons that we'll discuss it in a different video, what's happened here is that it's rebounded or reflected off the inside of this material, which is called total internal reflection. So at some point along the back of this block, what has happened is that rather than going through in a straight line like that, the ray of light has been refracted, as we would expect it to be, reflected off the inside, and then hit there where it's again refracted and passed in the opposite direction. So this process for shorthand is called TIR, but that stands for total internal reflection, and that is when the ray of light is greater than a critical angle and therefore reflects inside the material. So we have, first of all, when it's 90 degrees to the surface, it passes straight through, but if a ray of light hits a material that's going to enter into at an angle, then you'll get refraction, and refraction is the bending of light. And then in certain circumstances, you can then add on to that other processes such as total internal reflection.